Hello friends, today I will take some more chemical properties of the alkynes. In my last video, I explained you addition and some more property of the alkynes. Today I will take some more properties. First is the hydrogenation. Hydrogenation means addition of the hydrogen. You see alkynes, these are the double bond unsaturated hydrocarbons. Ethine undergo hydrogenation in the presence of the finally divided nickel as a capitalist. The addition takes place in two steps. In first step, addition of the hydrogen by breaking one double bond and form the ethylene, and then again one more bond breaks and finally it forms the ethane. That is ethine finally converted into the saturated hydrocarbon. Again, if we take the example of the propine, first one bond breaks, addition of the hydrogen takes place, then second bond breaks, and finally propine form the propane. This is simple hydrogenation in the presence of the nickel or the palladium as a catalyst. Now, the point is that how this reaction can be controlled to first stage. Listen, when ethine reacts in the presence of the palladium barium sulfate catalyst in the presence of the quinone. This is known as the lateral catalyst. That is catalyst palladium with barium sulfate in the presence of the quinone. Addition of the hydrogen takes place only first step, that ethine is converted to the ethylene. Listen, addition of the hydrogen can be controlled to first step, that is the ion converted to the ene. So in the presence of a catalyst palladium barium sulfate in the presence of the quinoline, which is known as the Lindelof catalyst, this reaction is stopped, that is ion is converted to the ene, that is ethine converted to the ethylene. Now, if we take an example of the non-terminal ion, that is put to ion. When hydrogenation takes place in the presence of the Lindelof catalyst, that is palladium barium sulfate in the presence of the quinoline, we find that it forms the cis but to ene, that is cis form of the but to ene. So this is the hydrogenation of ethine, propine and the but to ion. Now I will take the important reaction, that is oxidation. Oxidation, first, that is a combustion. Two molecules of the acetylene, when burns completely in the presence of the oxygen or the air, it burns a blue flame with a very high temperature. That is about 3000 K heat is evolved, and this is so much high temperature that this reaction can be used for the welding purpose. So that is known as the oxyacetylene flame. So combustion in air or the oxygen, it gives a very high temperature, that is complete combustion, blue flame, very high temperature, which is used for the welding purpose. Now come to the ozonolysis, that is oxidation with ozone. O3. Now ethine reacts with ozone. In first step, a unstable compound, that is ozonide, is formed, which further decomposed with the zinc dust in the presence of the water. It forms the diketoketon, that is the glyoxal. This is diketo compound, that is the glyoxal. So ethine react with ozone and then decomposed with zinc dust in the presence of the water. It forms the glyoxal, that is the diketo compound. Now if we take the example of the propine, again first a ozonide is formed, which is unstable. This is further decomposed with zinc and water and form the 2-oxopropanol. So the point is that these ozonolysis form the diketo compounds. Now the most important is the oxidation with alkyne camenophore. You see, alkyne camenophore, it is a pink in color, that is also known as the Bayer's reagent. This ethine, when react with camenophore, alkyne camenophore, that is oxidation, at low temperature, it converts to the oxalic acid and the pink color changes to the colorless. It is a test for the case of the alkynes. That is, alkyne camenophore oxidize the ethine, which is pink in color, to colorless compound, that is the oxalic acid. This reaction takes place at low temperature. Now, if we take the example of the propine with alkyne camenophore, at low temperature, it forms the pyruvic acid, that is the keto acid, CH3COH, that is the keto acid, pyruvic acid, CH3CO, and the COH. So at low temperature, it forms the pyruvic acid, but at high temperature, complete oxidation takes place to form the acetic acid. So at low temperature, it forms the keto acid. At high temperature, that is 373 to 383 K, it forms acetic acid. Now, if we take example of the non-terminal ions, that is 2-bit ion, at low temperature, it forms the biacetyl, that is the diketo compound. At low temperature, this bit 2 ion, it forms the keto compounds, that is biacetyl or the butane 2,3-diol. But at high temperature, that is 373 K to 383 K, it is completely oxidized to form the acetic acid. So this is the oxidation and the hydrogenation. In my next video, I will explain some more properties. So if you like my videos, please share and subscribe. Thanks very much.